chapter 1.8. Chapter 1.8, we are going to solve other type of inequalities. Now, the book says they solve other type of inequalities. I'm going to say the other type of inequalities is one part is quadratic inequalities. Okay, number one, we are going to do quadratic inequalities. So we know from chapter, I think it's chapter 1.6, some quadratic inequalities are also given to you in like fourth power, right? And we convert that to a quadratic equation by using the substitution, right? So quadratic inequalities, I'm going to say higher power that convert to quadratic inequalities, right? Remember we did the examples of higher power with the x to the power 4, and then we converted into quadratic equation. So I'm going to say some examples, you're going to have this, and also you're going to have power 4, right? Power 4 also. Equations with higher power. Higher powers than quadratic, okay? Could be 4, but we are going to use, so far we have not solved equations of higher power. The only way we know to solve equations of higher power is doing what? Only way we know to solve equations of higher power is doing what?
Substitution.
Using the substitution method. That means using the substitution for a quadratic formula to use the quadratic equation form, right? Right? Converting the given higher power equation to a what? Quadratic equation. That's the only way. So later on we are going to work on some other techniques of solving higher power equations. Okay. So let's work on this for now. Okay. Quadratic inequalities. So example number 1, I'm just going to give you x squared minus plus 5x plus 6. Is this a quadratic?
Yes.
So you can see, this is we are very familiar with this quadratic part of this, but this is not a equation, this is what? Inequality. Okay. Now this is solved little differently than what we usually do with linear inequality. Okay. So you guys know, note here. So let me give you a diagram of this. Note here. Let's say if we have something like this, y is equal to this. We are going to talk about functions big time. Next, I think after this, next week we are going to talk about library of functions, all type of functions big time. So let me, for now, I'm going to say x squared plus 5x plus 6. Have you guys seen this before? Yes, this is how this is the equation of two variables, and we know how to graph this, right? So instead of this, so let's see, using this y, I'm just going to graph this part. Graph this part. Y is this going to be, this is the y value, this part is the y value. So I can graph this part, okay? This is like f of x, function f of x. Function is a graph. Okay, so if we graph this one, the best thing first to do is, we already know how to graph this quadratic equation using like a couple of methods, different methods. But the first method I would like to know is first find the x-intercepts. find the intercept. So these are x and y intercept, and then find vertex, find y intercept, and use axis of symmetry, right? So remember, this is review, guys. So I'm just going to use this to graph this really fast, right? So how do you find the x-intercept here? You have to make the y coordinate equal to 0, right, to find the x-intercept. So make y equal to 0. So I'm going to find x-intercept. Y is equal to 0, so get 0 is equal to x squared plus 5x plus 6. This is review, so I'm just going to go this through real fast. X and x, what do you get here? 2 and 3. So how do you make the x-intercept now? Solve this, right? Solve this, so we get x equal to negative 3 and x equal to negative 2. That's the x-intercept. What's the y-intercept? How do you find the y-intercept of this? Make x equal to 0, right? Y-intercept means where the graph crosses the x-axis. When the graph is crossing the x-axis, the x-coordinate, that means x-coordinate is, y-intercept means where the graph crosses the y-axis, sorry, right? Graph crosses the y-axis, then the x-coordinate is 0. When the graph is crossing the y-axis, x-coordinate is 0, right? So we make x equal to 0. So if you make x equal to 0, y is equal to what? 6. Y is equal to 6. So we know x-intercepts are negative 3 and 0 and negative 2, 0. Y-intercept is 0, 6. This is y-intercept. We're supposed to get the vertex here. How do you get the vertex? If you graph this completely, how do you get the vertex? Now for inequalities, we don't have to graph this completely. And for now, I'm just going to graph this, okay? What's the vertex? X-coordinate of the vertex is negative b over 2a. You guys familiar with this? You guys know this, right? This is the x-coordinate of the what? Vertex. Guys, this is beginning algebra, way beginning algebra, okay? Math 117 or beginning algebra, beginning part of Math 118, Math 115, okay? So what is this x-coordinate? What is negative b? Negative 5 over 2, what is this? So x-coordinate is negative 5 over 2. That is negative 2.5. What's the y-coordinate now? Y-coordinate is you substitute the x-coordinate, correct? To solve for y-coordinate. 5x plus 6. So we get negative 5 over 2 plus whole thing squared plus 5 times 5 over 2 plus 6. So this becomes 25 over 4. Plus 25 over 2 plus 6. Common denominator is 4. So this is 25 over 4 plus 50.
24.
Pardon? 25 over 4. 5 times 5 is 25 over 2. Multiplied by?
50 over 4.
Multiplied by what?
2.
2. This is actually negative 5 over 2. So this becomes negative. So this is 50 by over 4 plus this you need to multiply by 4 also, which is
24.
24 over 4. So that gives us what? 49 minus 50 is? What's the y value here? Positive 49 minus 50 is Negative 1 over 4.
Negative 1.
This is the y value, right? So you guys know what's the vertex. What's the vertex here? Negative 5 over 2, comma,
Negative 1 over 4.
this is the x coordinate, and negative 1 over 4. This is the y, this is the vertex. Vertex is where the graph, the minimum value of the graph or the maximum value, right? We know this kind of graph going upward or downward. Upward or downward? Up, right? A is greater than 1. So this is kind of review for all these. So let me quickly graph this and show you guys exactly how this graph going to be. Okay, so we are okay, so let me see. What are the x-coordinate, x-intercepts? X-intercepts, negative 3 and negative 2. This is x-intercept. Y-intercept,
0, 6.
Zero 6. This is the y-intercept. Vertex,
Negative 5 halves.
negative 5 half is 2.5. 1, 2, 2.5. And is 1, 4. This is the vertex. Okay. So throughout the vertex, what is it going? Through the vertex, what do we have? Axis of symmetry. You guys are familiar with this. Axis of symmetry is the line where the graph is symmetric. So we can pick the other number, so this is 6. How many units away? So we want to complete the graph, right? How many units away the other point supposed to be? This, through the axis of symmetry, this is a mirror image, right? So this is how many points away? 2.5. So 2.5 going to this side. So what is that going to be? Negative 5. Good? So this point is negative 5 and 6, right? So the graph is this. So the graph is to go through this, go through this, go through this, and go through this. Have you got? Everybody should know in this class, I did go through this today, I took a lot of time to go through this today. Graph, anytime given, graph a quadratic equation or quadratic functions, we are going to call this a quadratic function, right? Quadratic graph. Using these 4 things. X-intercept, Y-intercept, vertex and what? Axis of symmetry. You have done this, so we know what to do here. Now this is if it's an equation. If it's an equation or function, we call it a function, quadratic function. This is if it's a quadratic function. Okay? So in other words, if you have this as f of x is equal to this. F of x means the y value. So we are going to talk about functions next class in next week. So we are going to see this a lot. We are going to see lots of quadratic functions in this class. And also word problems that comes with quadratic functions. Okay? So first thing is we have to be very familiar of how to graph a quadratic function. For this class, are we given a quadratic function? What is this given? This class meeting, what are we doing? Inequality, right? We are given inequality. So now we are going to, I just want you to show something. So now let's go back to inequality. So we have the graph of this, so I'm going to have this as x squared plus 5x plus 6 greater than or equal to 0. Okay guys, now I want you to see something here. This is the y part, right? If this was just equal, we call this y, and this is the graph we have, right? This is the graph of, this is the y value, this is the y. This is the graph of the y value, okay? Now, what is this saying? Y is what?
Greater than,
Y is, so
greater than or equal to 0.
I can write like this, or it's the same thing, I can write like, yeah, that's all. So this is y value, y is greater. So in this graph, you're going to interpret this here. In this graph, what's the value that greater? Where's the value that greater? The graph value is greater than 0. What values of graph is greater than 0? From here to here, greater than 0, y value is always greater than 0, right? Here to here, y value is always greater than 0.
Yes.
The y value is greater than 0, find the graph, if this is the graph, we actually find in the x value, if you solve this means we are solving for what? X value, where the graph is, the y value is greater than 0. You see that? We are solving for x value, find the x value where the graph is, the y value is greater than 0. So now by looking at this, can you tell me what is your x values on here where the graph is greater than
0.
or equal to 0? Raise your hand. Who can tell me the x value where the graph is greater than or equal to 0 here?
The right.
You are, I'm sorry,
Matt,
Matthew. Okay, go ahead.
on the right.
On the right?
Yeah.
Okay,
Right.
from what, starting from what value to what value? You have to give exact every single x value.
0.
Every single x value where the graph is greater than or equal to 0.
0 to infinity.
0 to infinity. So if I take 0 to infinity, yes, the graph is greater than,
0.
from here to here we can see all this value. So at here the graph is going here, right? So graph is greater than 0. You are correct, but when we find solution, we are supposed to give all solution. This is not all, this is part of the solution. We need to find all x values. So if you say 0 to infinity, there are more x values where graph is, this is only a part.
Amari,
Amari, okay, go ahead.
would it be negative 7
Negative what? Negative 2,
to, yeah,
negative 2 to,
infinity?
negative 2 to infinity. Is negative 2 included?
Yeah.
This has equal, so negative 2 is included, right? So that means we are going to use negative 2, remember? So negative 2 included means what do you need to do? Close brackets to infinity. So this is good, very good. Part of it is still only a part, right? Starting from here to infinity, all the way to infinity, the graph is positive. You guys see that? This is all the x value where the graph is positive. Do you see any more here? Sharon?
Negative 3 to infinity.
Negative,
To negative 3.
negative infinity to,
Oh, negative
negative infinity to, negative 3. Very good. Do you guys see this? I just want you to understand looking at the picture, the graph. What are the x values where the graph is positive? After you do the graph, you look at the x values where the graph is positive. Okay, so so now we are going to look at, remember when we did that final graph, when we did the, what you call, the working graph, right? We did the working graph when we solved compound inequalities. We did the working graph and we look at the final graph and we came up with the final solution set, right? It's the same thing here. We have the graph here. This is more like a working graph. Okay, so we have the working graph. we look at the working graph and what question we are going to ask here according to the inequality. If this has less than or 0, we are only going to look at the x values where the graph is negative, y value is negative. So it's based on what is given to us here. So now we look at this and we are going to say what? So look at this, what are the x values where the graph is greater than or equal to 0? Negative infinity to negative 3. Is 3 included?
Yes.
Yes. What do I write? I'm supposed to write here. Union. Very good. So union means we have to add this part to this part. So that this is the only, so this is the final answer. Final answer to this inequality. Everybody understand this? Now guys, here to solve this inequality, do we have to graph this exactly right? To solve this inequality, do we have to graph this complete graph? No. We didn't have to do the what? Vertex, right? We didn't use the vertex here. So now I just gave you an idea of how to graph a quadratic equation because this is review, right? I went through, it's good to know and you're not going to forget it. You have to know this, okay? And later on we are going to we have to know how to find the vertex of a quadratic equation to answer lots of word problems. The answers to a lot of word problems are in the vertex. So at that point, we are not going to go through how to find the vertex, so you have to be familiar with this, okay? So this is a good review, but question is, we don't need all this. So, but we need x-intercept for sure, right? Do we need the y-intercept? Do we need the y-intercept? I mean, it's okay to have it, but we don't need it. Okay? We don't need the y-intercept, we don't need the vertex. So, but we can solve by using only what? X-intercept. Okay, so now I'm going to do an example from the book where okay, let's do problem number 1.8, problem number 18. No, actually, let's do problem number 17. Okay, problem number 17. Number 17, 1.8. So number 17, what does it say? X squared plus 4x plus 4 x squared plus 4x plus 4 greater than or equal to 9. Okay, so this is my example number 2. Okay, example number 1, the answer that we are done. Okay, so what do you guys think? What's the first step we need to do in this solving this type of quadratic inequalities? What's the first step we need to do? We need to make sure the right hand side is supposed to be what? 0. Right hand side is supposed to be 0. Okay? So we already know how to do that. X squared plus 4x plus 4 minus 9 greater than or equal to 0. So go ahead, this factor this. X plus 5. X minus 1. Very good. Factor. So now what are we doing here? What are we doing here? Solving, right? Fine. So now we need to find the x-intercept. We only need to find x-intercept. Assume that this is an equal, we can find the x-intercept, right? How do you find the x-intercept? X-intercept. So x-intercepts are, we call the zeros of the graph. Zeros means where the y value is 0. X-intercept we call the zeros of the graph. Instead of x-intercept, now we are going to call the zeros. or the solutions of, right? Solutions of. So x-intercept is the zeros of the graph. If you look at these are the zeros of the graph, right? Graph is 0, those x-intercept, okay. So what are the zeros of the graph here? X is equal to
-5.
and x is equal to, these are the zeros of the graph, right? Okay, so all you have to know is this. So after we do find the zeros of the graph, so that's the first thing. The second thing what we need to do here is, we don't need to do the whole graph, okay? All we are doing is number 2, we are going to use the line test. Now when we did solve compound inequalities, you remember what did I say? You must use the working graph. For this class, it's a requirement. Even though you know how to do it differently, I ask you to, the requirement for this class, you must show the working graph. I have my reasons, I told you guys this before. If you don't do the working graph, most of the time you get it wrong. I have lots of experience, I've seen it many times. Okay, so I'm telling you, you need to do the working graph. Likewise, I'm telling you, this is a requirement for this class to show the line test. You must show the line test. So all you have to do is this. All you have to do is this. Draw the real number line. We only need the real number line. You don't need the plane, quadratic, the coordinate plane. Okay, we only need the real number line. It's always good to mark the 0 on the real number line. Then mark the x-intercept. What are the x-intercept? -5. So it's somewhere here, -5. Is -5 included in this problem? Yes. If it's not included, this is open circle. Now it's a closed circle. What's the other x-intercept? +1, it's here. Is +1 included? Yes. So these are the x-intercept. Now, after this, we want to know we know there's a graph growing this way or this way, right? We don't know which way yet. But we don't have to do the whole graph, do we? No. We only need to know where the graph is positive or negative. That's all we need to know. So now we are going to pick values here. We are going to check test points. So this is what you are going to do, check test points. So what are the test points we are going to have 3 intervals here, right? -∞ to 5, 5 through 1, okay? So 5 through 1 and 1 through, there's 3 intervals we are going to check for what? Test points, where the graph is positive or negative. Okay, so pick a point, so test points. So there's 3 cases, -∞ to 5 in this case. So what are the x equal to what? Any point you can pick. -6 or 8 or whatever the number, it's okay, -6, okay. So now you go back to the original one, which is x squared, after you solve it to 0, x squared plus 4x minus 5 greater than or equal to 0. So if you use the factor form here, use the factor form, which is x minus 5, right? Now substitute x equal to -6 here. What will happen? What's going to happen to this factor? This is -1, this is times. Substitute x equal to, same here, x is negative here, right? X equal to -6 here. So x equal to -6, this is -7. what do you think of the graph here? What's the graph value? Where's the graph? This is the graph. Remember, this is why I showed you the whole graph. So I want you to understand. If without me showing the whole graph, this doesn't mean anything for you right now, right? I showed how the graph is. Graph is a parabola in this case. We don't know whether it's going up or down, but we know in this interval, the graph value is what? Positive. Graph is positive indeed, because negative. This is the y value, the graph. This is the y value, the graph. Graph is positive. So, we know from here to here, all the value of the graph is positive. So, all these x values, graph is what? Positive. That's how you're going to interpret this. All this x value, the graph is positive. We are talking about a graph, not any numbers. Okay? Okay, now pick these numbers. Any number between here to here.
0.
0. It's always, if the 0 is involved in the x interval, always pick 0. So it's easier, right? If you put 0 for x, what value? Check for the next case is, this is one case, the other case is positive 5, negative 5 to 0. No, negative 5 through 1. Included, right? X equal to 0. At x equal to 0, what we have here? X plus 5 times x minus 1 greater than equal to 0. What do we have here? So we don't look at this. What's the y value here? 0. This is 5. Right? Negative 1.
Negative 5.
Negative, right? The graph is negative. Only thing we need to know, so from here to here the graph is negative. So if it's negative, write under. Positive, put up. Okay, do we have another section to check?
Yeah.
What's the next section we are going to check?
1 to infinity.
1 through
Infinity.
infinity. Including 1 through infinity, correct?
Yeah.
Okay, what's the x number we are going to pick?
2.
2?
Yeah.
Okay, x equal to 2. At x equal to 2, x plus 5, what's the y value?
It'll be 7 and 1, so it'll be positive.
7 here
Yes. And then 1.
and
2 minus 1 is 1.
1
Positive.
positive. All we have to know is the graph value positive or negative. We don't have to do the whole graph. But I want you to understand this is a quadratic graph. That's why we did all the review. Okay? So this is positive. Okay, so this is, now when I ask you to, this is a requirement, step number 2 here to what? Use the
Line test.
line test. You need to show this. You can do the mental math to this part, you don't have to show the work. I did show the work, you can write this down as your notes, so you know what to do, what numbers to pick. Okay? You can say, you're going to checking on, you can say this, check test points, x equal to what? What have we got? What did we get? Negative 6 and x equal to 0 and x equal to 2. So you are telling the reader these are the test points you took. But now the math part, we know you know this. We know you are mastered this. We don't have to show that work. You can do the mental math, you can do the scratch work on that, whatever it takes, you can do it, but you do have to come up, find an answer is where the graph is positive and negative. So this must show, you must show this. So give an indication of what x values you pick so that the reader knows what you did. Okay, remember we do the problems not for us, we do the problem for the community, right? You are teaching the others. So now, so I'm not going to have this part, but you should have it in your notes for the first time, how I got this, right? Okay, so are we ready, guys? Now we go back to the inequality. What's the inequality? The y value is, this is This inequality we boils down to this case, right? So this is the final inequality. It means the same thing, right? So what's the inequality now again? This is the inequality just like what we did the first example, correct? Right? So what is the final answer now? Final answer, by look at the working graph, negative infinity to negative 5 open, union, 1 through infinity, close, open. Any questions from this problem? It's exactly like we did the first example, only thing we didn't do the whole graph. But I want you to have in your mind, you're going to look at this is a whole graph, but we don't need the whole graph. Okay? Okay, so all that you have to do is this. Now I'm going to do my example number 3. Same thing. Example number 3. My example number 3 I'm going to do like this. X squared plus 4x plus 4 less than 9. What do you do, guys? So now you know the procedure, right? How to solve. You're not going to say, oh my gosh, what am I going to do now? No. You know the next step, exactly what it is, right? So we are going to make this equal to 0 first. This is the way we are supposed to solve this. Okay? And then we are going to do this. Now what are you thinking? What's your plan next? At this point, you're going to factor and find the x values where the graph, you're going to look at this as graph, right? In your mind it is a, what? It's a graph, right? It's a quadratic graph. You're going to find where the graph is 0. That means zeros of that whole y value. This is the y value, right? So in order to do that, we need to factor the same thing we did. Very good. So we know the x-intercept, right? Now we are going to do so this is first step. Second step is what? Second thing is?
Use the line test.
Line test. Very good. So line test. So I already did the line test for this. Now here the other thing that we need to look at is the x-intercept
It's not included.
part of the graph?
No.
No, we can't use the x-intercept, so there's no equal sign here, that's not part of the graph. So therefore when you do the x-intercept here, you do this. Those values are taken away. So what is this?
-5.
-5 and 1. Okay, now we already know the line test, right? This is the line test. So I already did the line test for this. Positive, positive, positive this way. This is negative, negative. Oh, sorry. So this is the line test. We already did that. Now I have to go back to the inequality again. What is this inequality asking you to do now? Asking you to find in this inequality.
It's less
Is
than
it
0.
less than 9?
What is it?
It's less than 0.
Yes. What is less than 0? You said it good, but it's not complete. What is less than 0? Less than means negative number. What are we looking at it here? What is this whole thing? Or this time we were doing it. What is this whole thing? The graph, right? The y value of this whole graph, right? This is the graph we are looking at it. Y value of this whole graph, where the y value of this whole graph, right? Less than 0. That means we are going to find the x values of this inequality where the y values are less than 0. Do you guys Does it make sense? We are looking for x values of this.
Or everything is less than zero.
This is the graph. Graph means the y. Okay? X values of this function. I can call this a function. Graph is a function. This is a function. Where the graph is negative, right? We only consider where the graph is negative, right? But we are looking for x values where the graph is negative. So what are the x values where the graph is negative?
5 through 1.
Yes, negative 5 through 1, open, open. This is the final answer. So box the final answer. So at the end you're going to ask that question. That's very important. You're going to take a minute, think, and ask the question correctly. What's the question you're going to ask? Where the graph is, in that problem, where the graph is negative. We are going to look at the area where the graph is negative. And then we are going to find the x values, right? Find the x values where the graph is negative. Does it make sense? We are looking for x values where the graph is negative. So that's what, when we are asked to solve this kind of inequality, that's the question they are asking you. The question they are asking you, when you solve this inequality, what x values, find the x values where for those x values the function, this part of the graph is negative. That's what it's asking for. It's little abstract, that's why I showed you the graph, the whole graph, and did all that work. Okay? So you're going to see different graphs on this side. Later on, you're going to see all kind of different graphs. We are going to do different functions, right? So you're going to ask this, whenever we have an inequality, we can ask, if you see a graph like this is, let's say we have this graph. Okay? Now this graph, or this function is called x to the power 3. Okay? But if we create the inequality on this and I say x to the power 3 greater than 0, right? What's the answer to this? What are the x values where the graph is? Where this graph is greater than 0. So starting from 0 to infinity. But we are going to do this later, graph, this type of graph. So if you understand this as a graph, see, mathematics is very abstract, very, very abstract. But you have to know exactly what it is. If you know the bottom, and you know the meaning of it, then you're going to build up, you understand stuff. Okay? So, okay guys, so we can do one more. So we're going to talk about this later. Right now only quadratic. We have more time? Okay, let's see. Okay, I'm going to do number 26. Number 26. I'm going to do number 26 real fast. Then you're going to do one problem class 1 or two problem class 1. Number 26. Can you read number 26 for me, please? Yeah. 1.8, number 26. What is it?
X to the power of 3
X to the power 3
plus 2x squared minus 4x minus 8 is less than or equal to 0.
Now this is a power 3 inequality. But you guys know when under quadratic equations, when we solve quadratic equations, we also solve equations with power 3, right?
Yeah.
Using factoring method, we also solve equations with power 4. So all you have to do is solve consider this as an equal and solve this part. That means find the x values. We only need to find the x values. So what are the x values? Where the graph is 0, right? So this is, we don't have to know how to graph this whole thing. We only need to get the x values. So now in order to get the x values, how are we factoring this? See whether we can factor this. What are you going to do, Sharon?
You can factor by grouping it. And
You
then
can factor by grouping it. Yes, we can factor by this one by grouping it. Yes. So this is, we talked about factor by grouping, right? Before? Remember I gave you all factoring, how to factor. So take these two, factor by grouping, x squared out.
and then
So what do you get here?
x plus 2.
X plus 2, good. What are you going to do here?
And then you're going to take out 4
Negative.
or negative 4.
Negative 4, very good.
X plus 2.
X plus 2. So you need to show this work. Next step,
And then
Group those ones.
use
x plus 2 we take out, open,
and then x squared minus 4.
x squared minus 4. So this is a very good factoring problem. And now what do you do here? Are we done here? Can we factor this further?
Yeah.
So we should know how to factor this using what?
Difference of squares.
Using what?
Difference of squares.
Difference of two squares. I gave you that also, how to factor as review exercise. Difference of x minus 2, x plus 2. These are the factors. So make sure you know whenever we have an expression like that, you need to already know this part. This is coming from beginning algebra, not even intermediate algebra. Okay? Less than or equal to 0. Very good. Okay. Now we have everything in factored form the way we want. Right? Now what do you do the next thing?
Working graph.
Working graph. Working graph. No, we need to find the x-intercepts, correct?
Yeah.
X-intercepts. What are the x-intercepts?
Negative 2 and 2.
So x-intercepts is x equal to negative 2, x equal to positive 2, and
It's the same thing.
yes, x equal to negative 2 and positive 2. So we're going to do the line graph here now. I mean test point. We have negative 2 and we know it's at negative 2 it is close. Do we know that? And then we have positive 2. So pick some numbers.
Negative 3, 0, and 3. Negative 3.
When x is equal to
Negative 3.
negative 3. What are the values? So line graph. X equal to negative 3. So you can do the test points, you can do the mental math. Negative. This is negative. This is negative. Correct?
Yes.
What is this?
Negative.
Huh? Negative. So negative number times negative numbers and negative number
Negative.
is negative. Correct?
Yes.
So all we don't have to know how the graph is doing here. I'm going to show you that later, okay, how to graph this. All you have to do is do this. So this is negative, negative, negative all the way, right? Okay. The other part. This interval we are going to pay 0. Do the mental math.
It's negative.
Negative.
Positive times, negative times,
So it's negative.
positive times, negative times,
Negative.
It's negative.
negative, right? So if we pick 0, that's positive, positive, and negative is still negative. Right? Now another point, another part,
It's be positive.
positive times,
Positive times.
Positive line
If it's positive.
and then positive.
what do you have?
It's positive.
Positive. Very good. Okay. Okay, class. So now what do we need to do here? What is the problem saying us to do here?
So from
Every
2 to infinity, it's positive.
We don't need the whole graph. Do we need the whole graph? Don't worry about the graph. That's when we solve this, we are not going to. I did tell you guys later on, we are going to talk about the multiplicity, how to graph that graph. But this one, we don't need to know the graph.
You was talking about the f of x.
Huh?
You was talking about the f of x.
F of x, the graph, the function. We don't have to know. This is not graphing part. This is solving inequality. All you have to do is this. Okay. So now, I'm going back to this, right? I'm going back to this, right? But we have to look at it. We are going to see this as a what? This whole thing as a
Diagram.
graph here. We are going to imagine a graph here, right? There's a graph there. So it makes sense. The problem makes sense to you. That's why I want you to have that graph. This whole graph is what? Y value, right? We don't have to know how to graph it, but we are going to look at that whole part is Y value. That Y value can go up and down in here, right? The Y value is going here, up and down, right? But we go back to the graph and we look at it, and now according to the given problem, this is the problem given, okay? So Sharon, can you tell me what are we looking for here?
Well, you want the negatives, so you do the negative and the negative.
Yes, so we are looking for, very good, we are looking for this graph, which is the Y value, where the graph is what?
Less than 0.
Negative.
Yes.
So we have an indication here, where the graph is negative. We know this diagram means what it means to us. There's some lines going, some curves or whatever it is going here. At this part of that curve that is going here, the graph is always below this is the x-axis, x-axis. Okay? That's what the problem is telling you here. So people who see this means a lot. Because this gives a huge story. This is not just some line saying some positive, showing some negative signs and positive signs. Okay? Now by looking at this, we are looking at, what are we looking at here? We go back to the problem, right? Again to inequality, and according to the inequality, we give our final answer. Okay, who like to give me the final answer for this? Negative infinity
To graph it.
to open,
Close.
close.
Close bracket.
Okay? Because we cannot consider the area where the graph is positive. Because the inequality says solve for x values where the graph is negative. Find the x values where the graph is negative. That's what the inequality is telling us to do. When you have an equation, the equation is saying find the x values where the equation is true statement, right? Find the x value where equation is true. Here find the x values where the inequality is true. This inequality is true. This means the graph is less than 0. So the final answer is this. Okay? And we don't do the graph. We don't have to know how the graph is going up, so we don't have to know that the multiplicity thing right now, or we don't have to know how the graph looks. All you have to do is this. Okay, so guys, I have like few minutes to write the steps. You guys tell me what we need to know how. So I did the example number 26 for you to see. You're not going to get always a beautiful quadratic inequality. Okay, you'll get something like this. You'll get something. I know I did something with x to the power 4 plus 2x to the power 2, something like this, right? I did this example.
Yes.
I did something like this, right? This example. So I did this example with an equal sign. Now we are going to do this with like something like this. I did this first day or the second day using the substitution. So you do a substitution to this and solve and find the x values. So you already know that part. So that's why it's important in this class. What we used earlier, we are using it again and again and again and again. We're using it. Okay? So guys, so you're also going to see on the homework x to the power 4. I did an x to the power 3 one, and I already did x to the power 4 how to solve before, right? You did for homework, so you're good to go. Okay, so what are the steps? So in this, today I'm going to write step at the end because I didn't want you to write the step at the beginning because I want you guys to make sense when I write the steps now. Because if I wrote the steps at the beginning, it might not make sense for you. Okay? So now you know the whole part, right? So what's the first step we need to say? This is solve higher power, right? Higher power inequalities. Okay, so what is it? What's the first step? Make the right hand side, right? Right hand side to 0, right? It could be less than or it could be one of these. Less than, greater than, less than or equal, greater than or equal, or this, right? One of these we have, right?
Yeah. Yeah.
And then the next one is, number 2 is what? Find the x-intercepts. X-intercept. So I'm not going to say how we are going to do it. Whatever the methods that whatever the factoring methods you're supposed to use,
Yeah.
Right now you're only going to get problems where you can factor the left hand side completely, factor left hand side completely and solve for x-intercept. We are not going to give problems for you in this section where you cannot factor. Okay? Right now, factor left hand side. What's step number 3? Step number 3 is create the working.
Right.
I'm sorry. Thank you. Create the, must do the right? Find the, or create. Create the, this we call it line test. Create the line test. We are going to work with the line test, right? We must do the line test. This is a requirement for this class, must do the line test. So this is, when I have these requirements, I have the stars. Line test, must do the line test, must do the line test. Number 4, find the, so we talked about this a lot. So I'm not going to write all the detail. If you want to, you can write your own notes under this. I'm just going to say find the final solution to the inequality, to the given inequality. So you know what question to ask. We discussed all this, right? Okay, so given inequality using what? Using what?
The line test.
What is it? Using Very important. Using step number 3. Using, we always, all the problems we did, what did we go to? We went to line test. You must have the line test. So please don't, you cannot say, oh, I have the right answer, you don't do the line test. I can't even look at the problem. I need to see the line test. But you don't have to do the whole graph now.
Got it.
Don't do the graph, you're not supposed to do the graph. But have an idea there is a graph going.
Yes.
That's what you're going to think. Okay? Yeah, this part represents a graph, right? The left hand side. Okay? Okay, guys. So now let me give you the homework number. Homework number 5.
So, are we not doing the homework online anymore? It's just gonna be like this?
Yeah, just this for now. I'll let you guys know. Okay?